In this video, we'll be talking about the quotient of powers rule and negative exponents. So essentially, what a negative exponent means is the reciprocal. So if we are looking at this problem 5 to the negative 2, typically in problems you don't want your answer to have negative exponents. So in order to make this negative exponent a positive, all you've got to do is cross the border. So imagine this border where there's a fraction over 1 and cross from, say, the numerator to the denominator. So in this case, if we're in the numerator, if we cross this whole thing from the numerator to the denominator, then that negative exponent will change sign and become positive. So 1 over 5 squared, and then if we simplify that, that's 1 over 25, because 5 squared is 25. Okay, so let's look at this again. Same idea, but with an x that's going to cross over the border and become 1 over x squared. So when it crosses from numerator to the denominator like that, the sign of the exponent changes. So the negative 2 becomes a positive 2. And that's true even if you want to cross over, if you start positive and you cross over, then it'll become a negative. So the same rule applies to either way. So here, we're starting in the denominator. So when we cross over the border, we're going to go from denominator to numerator, and we'll change that exponent from a negative 3 to a positive 3. And what's left behind is just a 1. So in this case, anything divided by 1 is itself, so we don't need to write the fraction with a 1. We can just write it as x to the third power. Okay, so those are the basics to give you a feel for how this negative exponent rule works. And now with these next few problems, we're going to look at some common misconceptions. So first off, people sometimes think that the entire problem crosses over, and that's not the case. It's only the base and the exponent on that base. So in this case, the 12 is going to stay put and remain in the numerator, and only the x to the negative 4 is going to cross over and become x to the 4th. So this would be our final answer here. Same thing in number 4, and so we've got this coefficient 5 and this coefficient of 7. Those two are going to stay put. So we have 5 over 7, and then the only things that will cross are the x to the negative 3, that'll cross down, and the y to the negative 8 will cross up. And of course, those negatives change to positive exponents. And then last, with number 5 here, we have coefficients that simplify, so we can at least do that. So 18 over 12 simplifies to 3 over 2. And then you've got to look at all of those different variables, and anything that has a negative exponent will cross, but anything that has a positive exponent is also just going to stay put. So the x to the negative 1, that's going to cross to the denominator and become x to the positive 1. But then the y and the z, those both have positive exponents, so those will just stay where they're at. So this would be our final answer, although normally we don't write exponents of 1, we just kind of leave it as that invisible exponent of 1. So there's some common misconceptions that can help clear things up for you as you go through problems. So now that we've talked about negative exponents, let's change gears and talk about quotient of powers. Now you may remember we've talked about this hierarchy where if you are doing a power problem, then with the exponents, you've got to multiply. If you're looking at a multiply problem, then you look at one level lower, and for the exponents, then you would add. So we didn't talk about dividing though, but really multiplying and dividing are like two sides of the same coin, just like adding and subtracting are like two sides of the same coin. So let's think with multiply, here would be a multiply problem. We know for the exponents, we need to go one level down and add. So in this multiplication problem, we would do 6 plus 4 to get x to the 10th. Now, what happens when we divide instead of multiply? Well, now, instead of adding the exponents, now we subtract. So 6 minus 4 is 2, and that's why our answer here is x squared. Now, just to give you a little bit of a conceptual understanding of why you subtract here, let's actually take a second to expand this problem out. So we have x to the 6th in the numerator, which is really x times itself 6 times. So that's 1, 2, 3, 4, 5, 6 x's multiplied together in the numerator. And then that's all over x to the 4th, which is 4 x's multiplied together in the denominator. Now, think about what we know about canceling things out when we have fractions. We're going to look for a pair, a 1x in the numerator, 1x in the denominator. That's a pair that cancels each other out. Same thing, we can do it again, right? Find another pair, 1 in the numerator, 1 in the denominator. Those will cancel each other out. X over x is really just 1, right? Let's keep going. We have this x over this x, those will cancel. This x over this x, those cancel. And we've run out of x's in the denominator that can cancel out. All that we're left with is these 2 x's in the numerator. What do you know? That means our answer is just x times x, because everything else canceled. And x times x, if we condense it back, equals x squared, which is exactly what we got up here. So the reason we're subtracting is really because we're looking at the difference between how many x's do I have all multiplied out in the numerator versus how many do I have all multiplied out in the denominator. And you look at that difference between those two numbers, and that's your final answer. Now, what happens if the number in the numerator is smaller than the one in the denominator? Well, you might be able to guess from seeing it all written out like this that our answer is going to be 1 over something. So let's see how this expands out with x squared over x to the 5th. Well, we would have x times x over x times x times x times x times x, right? Now, we've got a pair canceling here, another pair canceling here. That leaves us with 3 x's in the denominator. So our final answer is 1 over x cubed. So think of it as like there's this coefficient of 1 that you don't always see. So that's why we still have that 1 in the numerator. But all the x's canceled out. So 1 over x to the 3rd. Now let's tie this back in with our negative exponent rules from before. If we subtract like the rule says, we're going to get 2 minus 5. You always subtract your numerator minus your denominator when you subtract your exponents. So 2 minus 5 is negative 3. So really what we would be getting here when we do, when we subtract those exponents is we would be getting x to the negative 3 as our answer from subtracting. And what do you know? X to the negative 3, if we cross that border, this whole thing moves from the numerator to the denominator and becomes 1 over x to the 3rd, which is exactly what we got up here. So it all kind of connects. This negative exponent idea connects back with this subtracting rule that we see with division problems. All right, so finally, I'm just going to show you one more example or so to help you kind of get you on your way for the practice problems. So first off, you might think, well, why don't I just expand it out every time? Here's where knowing to subtract top minus bottom can be very useful, because when you have these bigger exponents, you don't want to multiply out x times x times x on and on 315 times. It's going to be much easier for you to do 315 minus 412. Look at that difference, and then think about, is your answer going to end up in the numerator or in the denominator? If it's negative, it's in the denominator. If it's positive, you're in the numerator. Okay, and then here's a final example for you where we want to combine x's and y's. So there's different ways of approaching a problem like this, but one would be to subtract our exponents. So for the x's, we can combine these guys by subtracting those exponents. So we would have 2 minus negative 3, And that minus negative is kind of like a plus. So 2 plus 3 equals 5. So in our answer, we would have x to the 5th. And then for the y's, we would do -3 minus -1. Again, subtracting that top exponent minus the bottom exponent. So again, we've got that minus negative, which is kind of like a plus. So -3 plus 1 is -2. So we've got y to the -2. So this would be a decent answer, but again, because we have that negative exponent, it's better if you can send that across the border, that y to the -2, so that there's no negative exponents in our answer. So we're going to send this y to the -2 across the border and have x to the 5th over y squared. And that would be our final simplified answer. So this brings everything together, and that's a wrap.